Guys, welcome back to the channel. In this video we are going to discuss the implementation of full subtractor with the help of 2x1 mux, 4x1 mux, 8x1 multiplexers. So let's get started. So this is the full subtractor block diagram and the circuit diagram. So if you want full detailed explanation of full subtractor, I am giving the video in the description box. Check it out. So in this video we are just going to implement with the help of mux. So we can implement in three ways. First method, the full subtractor implemented with the help of 8x1 mux. So let's see how to do that. So before seeing that, I have already implemented the full adder with the help of multiplexer. So in that video I have given a detailed explanation. So if you see that once first, so you will be very clarified with this video. So first see that video and come to this video, because that is very important video and this video is interlinked with that video. So let's see the first method, that is with the help of 8x1 multiplexer. So the first thing that we are required is difference. So before that, this is the truth table. In the truth table we have three variables, a, b, b in means borrow in. So we have difference and borrow out, that is. So within these three means this 8x1 multiplexer, we can say that for n variable we can have n select lines. So in this we have three variables, so we have three select lines, a, b, b in, and we have all the different inputs applied over there. So if we want anything, we can apply a, b, b in, and we can get the difference d. So in the same fashion, if you want the borrow out, b out, so that is in the minterms, the position 1 2 3 7, if you observe in the truth table also. So you just need to apply all the 8 inputs. So as we are having outputs in the truth table, so the same output we have to apply as inputs in the 8x1 multiplexer. So if you want anything, we can just apply a, b, b, and we can get that output, specific output. So if you observe, if you want the d7, that is 1, so you can able to apply a, b, b in as 1 1 1, then you can obtain the last bar out, that is b7, that is 1. So I hope you understood the first method or the implementation with the 8x1 multiplexer. So the next method that we are going to implement or see is the with the help of the 4x1 multiplexer. So in this also we are going to have two things, that is one is difference and second is borrow. So going we have some depth concept, that is 2x1. So let's see with the first 4x1. So we already discussed about truth table. We know the minterms, that is 1 2 4 7 for difference, 1 2 3 7 for borrow. So in this, the second we have to observe that for n variables we have to use n minus 1 select lines. So let's see how to do that. So this is exactly similar to the full adder. So if you observe here, full subtractor in the 4x1 by using 4x1. So the first, the AB is applied as the select lines. You can observe over there that I have directly applied that AB as the select lines. So now we have left with only the variable C. So that C where we need to apply. So that C can be applied as input. So if you observe the difference and the C, we have to compare both of them. So if after comparing you can see that both are same, that is, so D is equals to C. So we have to express all the outputs in terms of C. So after expressing, we can see that the first one, that is D naught, that is C. Likewise, you have to find all the output expressions in terms of C. After that, you can apply simply to the 4x1 multiplexer as inputs. So this is the difference block diagram of 4x1 multiplexer. So I hope you understood the difference. So let's also see the borrow for the 4x1 multiplexer. So now you can see the borrow is 1 2 3 7 minterms. So in the same fashion, you have to highlight the two groups and you have to form the borrow output. So if you observe that B out, so for the first case we have relation, that is B and C are same, so B out is equals to C. So in the last case also that is same, but in between we do not have any relation, but B borrow is changing, B out is changing from 1 to 1 or 0 to 0. So final B out would be 1 and 0. So apply same to that. So if you want more details about these things, so check out our full video, that is full adder. This is similar to that, so that is why I am going very fast in here. So if you want to represent the same thing in the format of the full detailed things, so if you observe the difference, that is 1 2 4 7, we already know minterms. So C can be elaborately shown as that C and C bar, and you can join with the 4x1 multiplexer. So like that you can able to represent the difference. So if you want to represent the borrow, that D naught and D3 is C both of them, so you can join both of them and represent single line, that is C. So in between D1 is 1 and D2 is 0, so you can simply represent the borrow also like that with the help of 4x1 multiplexer. This is full subtractor. So the forced implementation is also the full subtractor. This is also full subtractor, but the difference is the first method is with the help of 8 cross 1. This is the with the help of 4 cross 1 multiplexer. And finally, this is the 2 cross 1 multiplexer, that is implementation of full subtractor. So if you also see, we also note the truth table, and in this case, if you have 3 variables, we can implement that with the help of only one select line. We can speak if you have 4 variables also, we can have with one select line, because this is a separate case. This is about this more we have discussed in the previous video only, that is full adder implementations. Okay, let's see the things that we need the difference with the help of 2 cross 1 multiplexer. So for the difference, we have two terms, that is I0 and I1. Those are the variable inputs that I can say. So for the first difference, let's see. So for the first difference, that we need to consider a k-map of 3 variables, because in this also we have 3 variables a, b, c. So I have drawn the truth table of the 2 cross 1 multiplexer also, that is when a is 0, output would be I0, a is 1, I1, means a is 1. So means the select line our input would be I1. So if you observe in the k-map that you are going to place all the ones, so we are going to follow row by row. So first we have 1 and 2 positions, that is min terms. So you have to group separately. This is not like just normal k-map grouping. This is separate grouping for the 2 cross 1 multiplexer. So if you observe for the first one, we can make a group of 1. So that is b bar c. So in the second position we can see the b c bar. So simply I0 is equals to b bar c plus b c bar, that is b XOR c. I0 is equals to b XOR c. That's simply. So I also represented in the 2 cross 1 multiplexer also, see that. So the next thing we are going to obtain is I1 in the difference only. So this is difference only, but we have just completed one input. So for the second input, we are going to see the a is equals to 1 condition. For that also we have for the 4th and 7th positions. So 4th position is b bar c bar and 7th position is bc. That is simply we can add both of them. After adding, that is simply the XOR, that is b XOR c. So simply I also represent that in the 2 cross 1 multiplexer also. So I1 is equals to b XOR c. And finally, in the third implementation, that is 2 cross 1 multiplexer, we are going to implement the full subtractor, that is borrow. Now we are going to have. So in the borrow also, if you observe clearly, I took the truth table. So that is 0 1 1 1 0 0 1. Now if you consider the min terms of borrow, that is 1 2 3 7. So you have to fill the k-map according to that. So again we are going to follow according to the row wise. So the first condition for a is equals to 0. So for a is equals to 0, we have two groups, that is in the 1 3, that is one group, and the 3 2, that is one group, highlighted in blue and green. So blue group is represented C, because C is not changing. Green group is representing B, that is because B is not changing. So again we need to add both of them. So after adding, I0 is equals to B plus C. So I am representing in the 2 cross 1 multiplexer near also, see that in the position of I0. So if you consider for in the condition that a is equals to 1, you can observe we have only one term, that is in the 7th position. So that is corresponding to BC is B dot C. So simply we can say that I1 is equals to B dot C. So you can also observe that near 2 cross 1 multiplexer, I have changed that I1 to B dot C. So A is simply the selective line and BC is in terms of the inputs. So totally 3 variables are covering successfully. So now we have draw the basic block diagram of full subtractors with the help of 2 cross 1 multiplexers. So difference and borrow is there here. So now you can able to represent just block diagram this is. So difference simple, that is B XOR C and B XOR C. So and borrow also B plus C and B dot C, that is I1 and I0. So simply we can represent like this, or we can able to expand and we can represent. So expanded form we'll see now. So this is the expanded form, because in the first I0, in the difference we have that B XOR C. So simply I take an XOR gate. So in that I1 we had that XOR gate. So instead of taking XOR gate, you just need to invert the output of the XOR gate, that gives our XOR output. So I took a NOT gate over there for I1. So I hope you understood that D. So if you consider for B, that is for borrow. So I0 is B plus C. I took simply a B plus C. So I1 is B dot C. So simply take AND gate. So you are going to obtain the borrow B. So I hope you understood that expanded form also. I hope you understood video how to implement the full subtractor with the help of 8 cross 1 marks, 4 cross 1 marks and 2 cross 1 marks. So for all these I have explained the borrow and the difference also. So thanks for watching up to now.